Hey, welcome back to your favorite trigonometry class. We're going to take a look now here. We stopped as we're about to examine this function of the form a tangent omega x plus b. So if you look at this 3/2 here in front, we're going to, if you want to think about your transformations here, this is going to vertically stretch it by a factor of 3/2. Okay, that's what that a is going to do. If that thing's bigger than 1, we're going to have that vertical stretch there. The B position, so this 1/2, that's going to be a vertical shift up half unit. Okay. Let's go ahead and start graphing this thing by hand. So if you're thinking about this function here, we've got our period is pi over omega, and the omega is the 1 right there, right? So it's just pi over 1. So period's still pi for this tangent function. Now let's think about our vertical asymptote for a minute. This is 3/2, and this is tangent, so sine over cosine, plus a half. So our vertical asymptote would be, where is this thing undefined? Well, wherever the cosine is 0. We know the cosine at pi halves is 0. We know the cosine at 3 pi halves is 0. We know the cosine at 5 pi halves is 0, and so on. We also know the cosine negative pi halves is 0, and so on. So if the vertical asymptote would then be, the general form would be pi halves plus pi k, where k is an integer. And that'll take care of all of those vertical asymptotes. So you've got one at pi halves, three pi halves, negative pi halves, and then we're going to start plotting some points here. Delete a little bit here so we can plot some points. By the way, our domain will be everything except for those vertical asymptotes. All right, so let's get some points here. Let me throw in. Well, let's go 0. So we got sine of 0 over cosine 0, right? That's the tangent 0. We know that the sine of 0 is 1. We know the cosine 0 is sine 0 is 0, cosine 0 is 1. So 0 times that 3/2, we got 0 plus a half, 0 comma 1/2. There's 1, 0 comma 1/2 right there. My goodness, this dang thing's not letting me put a little dot there. 0 comma half. Let's go halfway to pi halves. So let's plug in pi fourths. I know you could plug in pi 6, but pi fourths is a nice one because I know the sine of pi fourths and the cosine of pi fourths are the same thing. They're both root 2 over 2. So I got 3/2 times root 2 over 2 over root 2 over 2, which is 1. So I got 3/2 plus 1/2 is 4/2 or 2. So pi fourths, comma 2. And I could throw in like negative pi fourths. And if I throw in negative pi fourths, I don't want to do that right. This here. Plug in negative pi fourths. And then I'm going to get the sine there is negative root 2 over 2. The cosines of negative pi 4 is root 2 over 2, which would give you negative 1. So then you'll have negative 3 halves plus 1 half, which is negative 2 over 2 or negative 1. And now I can kind of draw this. You see how instead of 0, 0, I have 0 comma a half because it's been shifted up a half. Okay, and that's what's going to happen. Just going to repeat this. If I can kind of draw that. Okay, so vertical stretch by a factor of 3/2, so it's a little steeper than the normal tangent increase, if you will, and it's bumped up a half. In fact, let me give you a look at that with this, and I'll show you. So here's tangent in red. Let me go from negative 3 pi to 3 pi, I guess. The steps be pi halves. All right, so there's our tangent function. Now, let's say we just put 3/2 in front of the tangent. Can you see how in blue, see how it vertically stretches it as compared to the original red tangent function? So the blue is vertically stretched, and then this thing is bumped up a half. So it takes that original 0, 0, bumps it up there to 0 comma a half. All right, and you could, if you want to, get some points from there. 0, pi, 4s, negative pi, 4s, and so on. You kind of get some points there to graph on that blue line there. Okay, so that's the transformation set. Now let me go back here. Our domain is everything except for our vertical asymptote. So if you notice, it'll be pi halves k, where k is an odd integers, how they say it. I wrote it as the domain being pi halves plus pi k. That's another way to say that. Okay. So write that here. So domain x such that all reals except for, I'll do it this way, cannot be plus minus pi halves, cannot be plus minus 3 pi halves, plus minus 5 pi halves, so on. Or you could say all reals except for pi halves plus pi k, where k is an integer. That's another way to say that. Or you could just do the interval notation, not touching negative 3 pi halves up until negative pi halves, so everything in between is fine. These are parentheses, so you're not including the negative pi halves and the pi halves and so on. Anyways, it keeps going. Range, on the other hand, if you notice, it's going to encompass all these y values, right? So the range is all real numbers. Or you could say negative infinity and positive infinity interval notation. Okay? All right, 3 cotangent 2x. So now I'm going to start out and then we'll kind of take a look with Desmos here, kind of make this a little bit quicker. I think you're kind of getting the idea here, hopefully. But your period is pi over omega. This is going to have a horizontal compression because that number is bigger than 2 there. So in this case, your period is going to be pi half. So it's going to, as compared to that cotangent function, it's going to shrink that period. Okay, so it's going to repeat it every pi halves amount. And then number 2, you want to think about this as 3 times, this is cosine of 2x over sine of 2x. In fact, let's go ahead and plot a few points on this after we do the vertical asymptotes. Where's this thing undefined? Wherever the sine of 2x is 0. And well, we know the sine of 0 is 0. So in other words, what x value causes that to be true? X value is 0. We also know, again, this is where it's undefined, we also know the sine of pi is 0. What x value causes that? Divide by 2 both sides, pi halves. We also know the sine of 2 pi is 0. So what x value am I going to plug in again to make this undefined? Divide by 2, pi. Right, so it goes 0, pi halves, pi, 3 pi halves, 2 pi, and so on. And same thing in the negative direction, it would be negative pi halves, right? So these will be plus minus in this case, if I do them in that negative direction, because I'm not sine of negative pi is also 0, and so on. So in general form, my vertical asymptotes will be pi halves k, where k is any integer, right? Because if k is 0, x is 0. K is 1, x is pi halves. K is 2, pi halves times 2 is pi. If k is negative 1, then I got the negative pi halves. K is negative 2, I got the negative pi, and so on. So that takes care of all those. So then I'd graph it, and I'd say, well, x equals 0, right down the middle. Pi halves is the next one. Pi is the next one. 3 pi halves is the next one. And so on. And then I plot some points. So I plug in like pi force. That's a good one because 2 times pi force this gives me pi halves, and I know the cosine of pi halves is 0. I know the sine of pi halves is 1, so I got 0 over 1 is 0 times that 3 in front. This ends up being 0. So pi force 0. I could plug in pi 8, and now I've got cosine of 2 times pi 8 over sine 2 times pi 8. So that's cosine of pi force, which is root 2 over 2. Sine of pi force, root 2 over 2. So I get 3 times 1 is 3. When I plugged in pi 8, I got 3. So pi force is 0, pi 8 was 3. Anyways, I keep going, but this is going to look like this cotangent function. So it's decreasing, but this 3 in front right there is going to vertically stretch that. It's going to really stretch that thing out. And then it's just going to repeat that each time I graph this thing. Okay. Anyway, so I'm going to show you on decimal. It looks like tangent 2x. Clear these. You can kind of see that nicely there in black, right? All right, finally the cosecant function. So the cosecant, so 1 over the sine. So first of all, where's this thing undefined? Wherever the sine is 0, right? Well, we know that could be at 0, sine of 0, 0. We know sine of pi is 0. We know sine of 2 pi is 0. Same thing, negative pi is 0, sine of negative 2 pi, and so on. So it'll be pi k, where k is any integer. So I'm graphing this thing. I got a vertical asymptote at x equals 0, x equals pi, x equals 2 pi, and so on. And then we could just plot some points. So let's throw in pi halves. I know the sine, so this is 1 over sine pi halves, which is, sine of pi halves is 1. So that's 1. Pi halves, I've got 1. I can throw in like pi fourths. We got 1 over sine of pi fourths. I get a few points there, that'd be, what would that be, root 2, or about 1.414, about right there. Punch in 3 pi fourths, root 2 as well. Anyways, I plot a few of these here, and you'd kind of get this curve looking like that, right? Okay. Let me go over here to sine of negative pi halves. I throw that in. 1 over sine of negative pi halves, 1 over negative 1, so negative 1. Throw in negative pi 4, so get that negative 1.414. Throw in negative 3 pi 4. Same thing. Anyways, I kind of start drawing it over here. And what this does, it repeats this. So this period it's going to repeat this each time. This is your period. Okay, from negative pi to pi is a distance of 2 pi. It's got a period of 2 pi. And what it's going to do is it's going to repeat that as this moves on. Okay, so over here it'd be like that, like that. I'll show you on the decimals. And then I'll kind of show you how to compare it to this side. And it's all real numbers except for pi k, where k is an integer on that. Okay. So y equals cosecant of x. There's our cosecant. And let me show you with the sine in there. See the sine? See how they connect? See how they intersect right there? So the minimum, at least between 0 and pi on this, is the maximum of the sine. See how they meet? They're meeting right there at pi halves, 3 pi halves, 5 pi halves, right? So every pi halves plus pi k, right? K is an integer on that. They're meeting. Okay, interestingly enough. Now the range here, let me delete this. We go from negative infinity up to a negative 1, and then there's nothing in between, and then we take off from a 1 to positive infinity on that. All right. So let me So our domain, all reals except for wherever these vertical asymptotes are, right? So pi halves k, where k is an integer. I'm sorry, pi k, what am I doing? Pi k. Sorry about that. So 0, pi, 2 pi, and so on, right? Pi k, where k is an integer. So 0 plus minus pi plus minus 2 pi and so on is your domain, your range. Notice again it's coming up until -1. Hits that -1, then it takes off again, goes up. So -infinity up to -1 if you're going to do this in interval notation, and then from 1 to positive infinity, including. So y is such that y is less than or equal to -1, or y is greater than or equal to 1. That's how you talk about that with the range. All right, our last one here talk about is our secant function. So our secant function, well, secant is 1 over cosine. Where's our vertical asymptote? So you're thinking about that that same way. Where's cosine undefined? Secant of x. And you say pi halves, undefined, 3 pi halves, right? Cosine 3 pi halves, and so on. Now let's compare it to its reciprocal function, the cosine of x. In green, and you can kind of see, oh, they meet 0, 1, they meet a pi -1. It's kind of similar, except it's obviously shifted, but it's kind of similar to the cosecant as compared to this there. And I'll let you kind of analyze that. Our last function here is to take a look at cosecant of x, 2 cosecant of x minus 1, and think about those transformations. So you're looking at that 2 right there in front. You're thinking to yourself, well, that's a vertical stretch of the cosecant function, right? It's going to stretch that out. And then we're just going to drop it down 1. All right, so let's do that with transformations. 2 cosecant x minus 1. So let's do the cosecant function. Cosecant of x. So the first thing is you want to think about the stretch on it. 2 cosecant of x. As compared to green, notice instead of at pi halves 1, now it's stretched that out, vertically stretched that, it's now pi halves 2, right? You could take some other points like pi of 4 and it multiplies it by a factor of 2, right? It stretches that out vertically, so it takes that, stretches it out. But it's 2 cosecant of x, and then it drops it down 1, moves the entire green down 1. So it took that point that was up here at 2 and dropped it down. Took this point and dropped it down from -2 down to -3, right? So again, vertical stretch by a factor of 2 drops it down 1, right? And you could walk through that again by hand. And then your domain, everything except for your vertical asymptotes, your range is coming from -infinity up to this -3, nothing between, and then it takes off from 1 to positive infinity for your range, right? Domain is everything except for pi k, where k is an integer on that. All right, thanks you guys so much for listening. We will see you guys next time.